Okay, so a very good evening to all of you. In this live, we will discuss about the metals and non-metals part 2. So, please join the live session. So, welcome to the live session. And today we will discuss about the chemical properties of metals and non-metals. Before the day, we discuss about the physical properties. And we studied about some violations of the properties of the physical properties. So the physical properties doesn't distinguish properly the metals and non-metals. So we have to discuss the chemical properties of metal and non-metals that should differentiate the metals from the non-metals. Okay, so the first property is the burning of the metal in the air. So what happens when metals are burnt in air? So metals mean magnesium, aluminium. So now when metals are heated in air, they react with oxygen to form metal oxides. So, however, not all metals react in the same way or with the same intensity. We will discuss it later. Okay. Then we study the reactive series. When the reactive materials are informed in the series to high reactivity from high reactivity to low reactivity. So now metal plus oxygen produced metal oxide. So when metal is burnt in presence of oxygen, the product of this reaction is metal oxide. Okay. So for example, copper, when heated, reacts with oxygen to form a black coating of copper 2 oxide. So what is copper 2 oxide? This is cupric oxide. This is cupric oxide, okay, CuO. Why this is cupric oxide? We know that copper has 2 valency. One is 1 and the other is 2. So when this is Cu2, this is the copper 1 oxide or cuprous oxide. Okay? This is, and when CuO, this is formed the cupric oxide that we called copper 2 oxide. This is mainly the cupric oxide. Okay? And now the second example. Aluminium reacts with oxygen to form aluminium oxide, that is Al2O3. Okay, 4Al plus 3O2 that produced 2Al2O3. So this is a balanced equation. How? Al, the number of aluminium ions is 4 or atoms is 4 and there is oxygen atom in the number 6. And here we get 4 aluminium atom and 3 into 2, 6 oxygen atom. So we have to write the balanced equation in the answer sheet. Okay. So this is the example of the equation when the metals are heated in the air. So metal with oxygen produced metal oxide. Okay. There present heat. Okay. In the presence of heat. Okay. Do you have any doubt? So we have to go through the Next. Okay. So, now the next page. Nature of metal oxide. When I get the metal oxide, okay, M plus O, 2MO. Okay, when I get the metal oxide, now the basic nature, the nature of the metal oxide, we have to decide the nature. Is it basic or is it acidic? Is it basic or acidic? How to know it? The basic nature. What do you mean by basic nature? They react with acids to form salt and water. When it reacts with a base, it doesn't produce the salt or the water. So acids make water and salt with reacting with base. So base plus acid reacts with each other and produce salt and water. So when the metal oxides reacts with acids that form salt and water. So this is the nature, this is the basic nature of the metal oxides. So after we get the metal oxide, we have to decide this is basic or alkali. So base or alkali, what is difference between base and alkali? We have to know it. Okay. So insoluble versus soluble in which? In which solvent? In water. So, when the metal oxides are soluble in water, we called it alkalis. But most metal oxides are insoluble in water. They all are basic. They all are base. Okay. So, soluble oxides are called alkalis. So, what we get from it? The point is, all alkalis are base, but all the bases are not alkali. So, from where we get this point? Soluble oxides are called alkalis, and we know that the metal oxides are basic in nature. So the bases, when soluble in water, so the solvent is water, and when the metal oxides are soluble in water, we call them alkalis. So all the alkalis are bases, but all the bases are not alkali. Okay? So, do you have any doubt? Okay, this is the insoluble versus soluble part, but in which solvent? In water. So, most metal oxides are insoluble in water. So, the bases are not soluble in water. The bases which are soluble in water called the alkali. Okay. So now we have go through the next page. Okay. So amphoteric oxide. So what is amphoteric oxide? At first we have to know the definitions. Okay. So the metal oxides that can react with both acids and bases, the metal oxides that can react with both acid and base are called amphoteric oxide. Okay. So this is the definition. So some of the metal oxides such as aluminium oxide and zinc oxide, those are the examples of amphoteric oxide. So some metal oxides such as aluminium oxide and zinc oxide are amphoteric, meaning they react with both acids and bases. So what we get from the reaction? What is the products? Okay, which are the products from this reaction? So at first we have to take an example, just like aluminium oxide. Okay, we have this example. So now when the aluminium oxides reacts with acid, what will happen? So let's see what will happening. With acids, aluminium oxide plus hydrochloric acid, when it reacts with the acid, here we get the hydrochloric acid. Okay, so 6 atoms of hydrochloric acid with the aluminium oxide, we get the salt, aluminium chloride, okay, with the water, 3 mole of water. We can say it 3 mole of water. Okay, so we get the salt and the water. Okay, so this is the reaction with the acid. Now we have to go through the reaction with the bases. What will happen when it reacts with bases? So at first we have to take the example aluminium oxide. Okay, taking now the base, that is sodium hydroxide. What is this? Sodium hydroxide. Okay, so when the aluminium oxide reacts with sodium hydroxide, we also get salt and water. So this is the salt, 2NaLO2, okay, with the water. So what is the conclusion? The conclusion is the aluminium oxide, when it reacts with acid and bases, it produced salt and water. So it reacts with both acids and bases. So this is the example of amphoteric oxide. So we get one other example, that is zinc oxide. So this is an important question for you guys. So please concentrate in this portion. Okay. Okay. Now, do you have any doubt, students? If you have any doubt, please do comment. Okay. So this is the amphoteric oxide. Now the next page. Chemical properties of metal. So we have to note something out. Okay. So at first, not all metals react with oxygen at the same speed. So later we will discuss about the series, the reactive series, okay, reactive series of metal. So about the series we have to discuss. So now at first we have to know something, that is, not all metals reacts with oxygen at the same speed. Different metals have different levels of reactivity with oxygen. Highly reactive metals like potassium and sodium react so quickly that they may catch fire when exposed to air. So we don't have to touch it with the wet hands. Okay, in the laboratory, when you go through the tests, so when the sodium is highly reactive material, so do not touch it with bare hands or with wet hands. Okay. So now, where we are, not all metals react with oxygen at the same speed. Different metals have different levels of reactivity with oxygen. Highly reactive metals like potassium and sodium react so quickly that they may catch fire when exposed to air. Therefore, they are stored in kerosene to prevent accidental reaction. Okay? So, now the next page. Okay, and at room temperature, metals such as magnesium, aluminium, zinc and lead form a thin layer of metal oxide. So here we get the idea of protective, self-protected metal. Okay, we have to discuss it. Okay, at room temperature, metals such as magnesium, aluminium, zinc and lead form a thin layer of metal oxide on their surfaces. This oxide layer acts as a protective barrier or protective layer, and that prevents further oxidation reaction. So iron does not burn easily in solid form. So we have the violations again. So that is, iron does not burn easily in solid form, but iron filling burn rapidly when exposed to a flame because of their larger surface area. We know that the surface area, when the surface area becomes more larger, then the reaction happens faster. We know that, okay? So copper does not burn, but when heated, it forms a black coating of copper 2 oxide. So what is copper 2 oxide? At the very beginning, I told you what is copper 2 oxide. This is cupric oxide. This is cupric oxide, okay? Cupric oxide. This is not cuprous oxide, okay? This is cupric oxide. So, the valency of copper in copper 2 oxide is 2. So we get that Cu2 plus O2 minus and we get the CuO. So this is the valency of the copper. So copper 2 oxide means cupric oxide. Okay. So metals like silver and gold are very unreactive and do not react with oxygen even at high temperature. So this is called the noble metals. So when the question is asked that which is noble metal or what are the noble metals? So metal like silver and gold are very unreactive and do not react with oxygen even at high temperatures. So this is called the noble metals. Okay? Because of its stability and non-reactive nature. Okay, so gold, silver, platinum are the noble metals. Okay, and also this is called the coin metals. This is also called the coin metals. Okay. Okay. So, do you have any doubt in this section or in this portion? Please do comment. Anyone? Okay. So we can proceed through the next page, right? You don't have any doubts? Okay. So now, self-protector metal. Okay, self-protector metal. Anodizing is a process used to increase the thickness of the natural oxide layer on aluminium. So aluminium naturally forms a thin coating of aluminium oxide when exposed to air, which protects it from corrosion or from further reaction That okay, so from further reaction that may cause the decay of the metal, or we can say that it protects it from corrosion, or the anodizing protects it from corrosion. So the anodizing, that means the aluminium oxide layer or the coating of aluminium oxide throughout the surface of the aluminium. Okay, so During anodizing, this layer is made thicker by using aluminium as the anode in an electrolytic process with dilute sulfuric acid. Oxygen released at the anode reacts with aluminium to form a thicker protective oxide layer. So, the oxide layer is the protective layer. So, the metal oxide layer, that means the aluminium oxide layer is the protective layer. This layer can also be colored or dyed, giving aluminium products an attractive appearance. So, which metal known as self-protective or self-protector metal? So now we have the answer, that is aluminium. Okay, that is aluminium. Okay, this is a common question. Okay, so which metal known as self-protector metal? That is aluminium. So the process is by anodizing. This process increases the thickness of natural oxide layer on the aluminium. And aluminium naturally forms a thin coating of aluminium oxide when exposed to air. But when it goes through the anodizing process, the layer becomes thicker than the natural process. Okay. So this is the anodizing process also, and this is the self-protector metal portion. Okay. So do you have any doubt? Okay. Now, so let's study further. It is clear that sodium is most reactive metal among the metals. Magnesium reacts less vigorously, showing it is less reactive than sodium. However, reaction with oxygen alone are not enough to compare the reactivity of metals like zinc, iron, copper and lead. We know that? Okay, so now the reactions. We have to read the reactions. Okay. So the reactions are, at first, metals react with water to produce metal oxide and hydrogen gas. Metal oxide that is soluble in water dissolves in it to form metal hydroxide. But all metals do not react with water. We know that all metals do not react with water because of its reactivity series. Some metal has the high reactivity nature, but the other metal doesn't have that much reactivity nature. Okay, now, metals plus water, which metals reacts with water? Then it forms metals plus water, that metal oxide or metal hydroxide. So what is hydroxide? The formula which have OH, that is the hydroxide. Okay, that is the hydroxide. So plus hydrogen. So we know that CaO, this is the oxide. This is calcium oxide, okay? And CaOH whole 2, this is the hydroxide. So this is the difference of oxide and hydroxide. Okay, hydroxide means OH. Okay, the form OH present in the equation. So now, metals plus water produced metal oxide plus or metal hydroxide plus hydrogen gas. Metals such as potassium and sodium react violently with cold water. So, this is the precaution here, okay? Do not touch sodium or potassium in bare hands or wet hands, okay? So, with cold water, in case of calcium, the reaction is less violent. We know that in the case of calcium, the reaction is less violent, okay? We all know about CaO and CaOH whole 2, calcium oxide and calcium hydroxide. We all know about that. Okay, lime water. So now, So the reactions are, this is the balanced equation here. 2Na, and what is meant by this is the solid form or the solid state. Okay, so the solid Na, 2 mole of solid sodium plus liquid L stands for liquid. Okay, so 2 mole of water that produced, this is oxide or hydroxide. So students, is it oxide or is it hydroxide? Okay, this is the hydroxide because there presents OH in the formula. Okay, now 2NaOH aqueous, this is not liquid, this is the aqueous solution. Okay, this is the aqueous solution, this is the solution. This is not liquid, this is solution. So now 2NaOH, that means sodium hydroxide solution plus hydrogen, G means gas. If we write like this, H2 and then upper arrow, that also means the same thing. That means the gas. Okay, the gaseous state. Now, so 2Na plus 2H2O, 2 that produced, this reactant produced 2NaOH in the aqueous solution plus H2, that means hydrogen gas and heat energy. And heat energy. So is this endothermic or exothermic? Do the comment, please do the comment. This is endothermic or exothermic? This is questions for you. Okay, is this endothermic or is this exothermic process? Okay, so now for the calcium with the water, it reacts with water and produced calcium hydroxide aqueous solution plus hydrogen gas. Okay, plus hydrogen gas. And this is also a question for you. Is this exothermic or is this endothermic? So, okay, this is question for you. Now, the reaction of calcium of water is less violent. The heat evolved is not sufficient for the hydrogen to catch fire. So, how the metals catch fire? When it reacts with the water, which is a sodium and potassium. So, the reaction of calcium with water is less violent. The heat evolved. So, this is the point. Okay, this is the main point. The heat evolved is not sufficient. But for sodium and for the potassium, the heat evolved is more than sufficient for the hydrogen to catch fire. So, there occur fire. Okay. So, now, the next question. Okay. So, now the next portion. Okay. Okay. Magnesium does not react with cold water. It reacts with hot water to form magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen gas sticking to its surface. Magnesium reacts with steam to form magnesium oxide and hydrogen. So, magnesium does not react with cold water. This is an important point. With cold water, there is no reaction. So, it reacts with hot water to form magnesium hydroxide and hydrogen. So, it also starts floating due to the bubbles of hydrogen gas sticking to its surface. So, when magnesium reacts with steam to form magnesium oxide and hydrogen, this is the best reaction process because the magnesium better reacts with the steam, okay, than the hot water. So, the steam, magnesium with the water form the magnesium hydroxide. This is with the hot water. This reaction for the hot water. Okay. So, that produced magnesium hydroxide. So, that is hydroxide and this is the aqueous solution and this is the hydrogen gas. Okay. This is the hydrogen gas. When this reacts with steam, then this is the reaction or the balance reaction for this reaction. Okay. So, this is the equation. Magnesium plus steam This is gas because of this, because this is the steam. Okay, so magnesium with steam produced magnesium oxide, that is solid, and hydrogen gas. Okay, so this is the reaction of magnesium with the water. Okay, at various temperature, water at various temperature. Okay, so do you have any doubt in this portion? So now the next. Okay, metals like aluminium, zinc and iron do not react with cold or hot water. So the aluminium, zinc and iron metal do not react with cold or hot water, but they react with steam. Okay, to form metal oxide and hydrogen. So the reaction, the example of the reaction. What is this? This is the balanced equation of this reaction. So when G means gas, that means this is the steam of water. And this is the state, gaseous state of water, and this is the steam. So 3 mole of aluminium with 4 mole of steam, that produced aluminium oxide. This is the aluminium oxide and this is the solid form. Okay, this is the precipitation plus 6 mole of hydrogen gas. So they are produced hydrogen gas with the reaction with steam. Okay, so this is important. Okay, so do you have any doubt about the reaction with the water at various temperature? So now we have to study the next page. Example of reactions with dilute hydrochloric acid. So now with the acid. So the basic nature of metallic oxide, we know the basic nature of metallic oxide, but the metals like magnesium, aluminium, zinc, iron. So here some metals are base metals. When you study the periodic table, you got to know that. Okay, so now magnesium with the hydrochloric acid produced magnesium chloride and hydrogen gas. Okay, magnesium chloride, MgCl2. This is the symbol of magnesium chloride. Okay, so magnesium chloride with hydrogen, and when it's time for aluminium with the acidic reaction, aluminium with hydrochloric acid, that means Al plus HCl, that produced aluminium chloride. Okay, that produced AlCl3 with the hydrogen gas. Okay, AlCl3 with the hydrogen gas. Now for zinc with the hydrochloric acid, this reaction produced zinc chloride and hydrogen gas. And for iron plus hydrochloric acid produced iron 2 chloride plus hydrogen. So iron 2 chloride, that means ferrous or ferric chloride. Okay, what is mean by iron 2 chloride? Is it ferric or is it ferrous? Okay, do comment. Can anyone give the answer? Iron 2 chloride means ferric or ferrous chloride? Okay, so no one. So now, magnesium reacts the fastest and produces the most heat. That is most exothermic reaction. And the reactivity order is magnesium, aluminium, zinc and iron. And now copper does not react with dilute hydrochloric acid. No bubbles, no temperature change, indicating it is less reactive than hydrogen. So this is less reactive. So we are too close for the reactivity series. Okay, so it is less reactive than hydrogen. Okay, this is those are the conclusions of the reactions. Okay, now aqua regia. What is aqua regia and what is the use of it? Okay, the noble metals like gold, silver, that means aurum, argentum. Okay, this is insoluble in water. So how to dissolve it? So the answer is aqua regia. That can dissolve it. Aqua regia is the freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. Okay, the ratio in 3:1. So what is aqua regia? Okay, what is aqua regia? Aqua regia is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in a 3:1 ratio. So the hydrochloric acid portion is much greater. Okay, so with the hydrochloric acid and nitric acid, so concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1, we get the mixture that is called aqua regia. So this is freshly prepared. Okay, freshly prepared mixture. So it is highly corrosive and released fumes. This is highly corrosive and releases fumes. Okay, it can dissolve noble metals like gold and platinum which do not react with individual acids. So which do not react with individual acid, that can dissolved by the aqua regia. So this is corrosive. Okay, right, this is corrosive. Now the next page. Highly reactive metals have the ability to push out less reactive metals, to substitute the metal, to take the metal's place. Okay? Highly reactive metals have the ability, when we go through the thermic process or we read the thermic process, this is the example of this kind of reaction. Okay, so now highly reactive metals have the ability to push out or displace less reactive metals from their salt solutions or molten forms. This process serves as a reliable test for determining the relative strength of different metals. So which is more strong, that can displace the other and takes the metal's place. Okay, now if metal A displaces metal B from its solution, then metal A is confirmed to be more reactive than metal B. So now from this method we can get the series which is more reactive and which is less reactive. Okay, the general equation, metal A plus salt solution of B. Okay, that's salt solution of A plus metal B. So the principle of metal A displaces metal B. So okay, so now the reactive series comes to the show. Okay, the reactivity series is a standardized list where metals are ranked based on their chemical activity in descending order. Metals at the top are most aggressive in reaction. That means that is more or most reactive. while those at the bottom are the least reactive, that calls noble metals, that are non-reactive in nature. So which are non-reactive, that those are noble. This is common, okay? So the table, we go through the table, okay? We read the table now. So at first we have to know in the arc of the series or in the rank, okay? In the top series, okay, we get the most aggressive, that means the more reactive. And when we go down, we get the less reactive. So now the table, okay? So we have to study the table. So this is the table, okay? Now, this is the table. This is reactivity level and this decreases. Now, the potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. Now, the least reactive, gold is least reactive. Gold is least reactive, okay? Silver also a least reactive metal, but is more reactive than gold, okay? So now the potassium is the most reactive, and in this series the reactivity decreases. So when we go through the zinc, when we read the zinc in the series, this is in the middle portion. That means this is not most reactive or not least reactive. This is in the middle portion, okay? So potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. So we know that copper is less reactive than zinc. So when we get the CuSO4 with the zinc, okay, zinc metal when reacts with copper sulfate, okay, then it displays the position of metal and take the place. So the reaction, in this reaction, the product becomes ZnSO4. This is the substitution reaction or the displacement reaction. This is single displacement reaction, okay? This is single displacement reaction or substitution reaction. And there comes the Cu. So this zinc takes the place of copper, okay, and displace this metal because this is less reactive and this is more reactive than copper. So it takes its place, okay? So that's how the reaction occurred. And we get the idea from the table. This is the reactivity series, okay? So for today, we have to study about this reactivity level or this series. So that's all for today. You have to study it, okay? And then we will discuss the next portion of the chapter in the next live, okay? So bye for today, and that's all, dear students. Okay, and so we have some points to discuss also. So after discussing it, we have to close the live, okay? So now, iron versus copper. Based on the series, iron is placed above copper, okay? We go through an example, okay? We read an example of the displacement reaction already. So now, therefore, in a reaction between the iron nail and copper sulfate solution, iron will displace copper because it is more reactive. So since not all metals react with water, oxygen or acid, displacement reaction provides the most comprehensive evidence for arranging metals in a specific order of reactivity. So this is the importance of the reactivity series, okay? This is the importance of the reactivity series. So I think there is no doubt about this portion. So that's all for today. Okay, dear students, and thank you to watch the live. Okay, bye.